Okay, I'm on page 242. I'm back. We're gonna do this. So this first question is actually a review if you made it to the end of the last part. So we made two cylinders. They had the same exact height. The heights are measured along the x-axis, which is like really common. If you're going around the x-axis, that will always be the case. If you want to be able to make this process very general, we're always going to make that true about the height. What? If we want to be able to make this process very general, we'll always need that to be true. Okay, about the heights, not about, oh, I got it. We always want the heights to be equal sizes. Man, that was confusing to me. I don't know, you may have just read it and gotten it. All right, so the heights are along the x-axis. So we call them delta x's. They're little slices, little changes in x. And delta x is constant, right? So for two cylinders, if you remember, we did delta x was 4 minus 0 divided by 2, which gave us 2. All right, if we were going to use 4 cylinders, then we would be doing delta x. So you're going from 0 to 4 on the x-axis. You're going to cut it into 4 equal parts. So it's going to be 4 minus 0 divided by 4, which is 1. So each of them will be just 1 unit high, but the heights are along the x-axis. And then you find the radius, and then you rotate around the x-axis. So what we want to do is find what are called evaluation points. These are the points at which you evaluate the radius. So what I'm going to do is, in this space over here, I think, I'm going to draw the region again. So let's go here, and then here, and something like this, right? And so this is 4, this is 0. This will be 2, 3, and 1. Okay, so we call them x sub I. Those are your evaluation points. So the first one, you're going to start at 0 and move delta x, right? So this is delta x. So your first rectangle will be like this. So your first evaluation point, x sub 1, is going to be 1. At x equals 1, we're going to find the radius. The radius is going to be f of 1. Ew, that's not great. All right, let's make it bigger. Let's clean up this handwriting a little bit. So f of 1. So remember, the function in this case is x squared. It doesn't need to be x squared. It could be sine of x. It could be like anything. This is like a basic example, so we're using a basic kind of function. So it's going to be 1 squared, which is 1. Okay, the volume for this particular one is going to be pi r squared h. So pi times 1 squared times 1, so just pi. Okay, so that's our first one. Now what we do is we move again by delta x. It's always going to be by delta x. We get here. When we get to 2, that's the right endpoint, so we go up. That's our radius. There's this. So our second evaluation point is going to be 2, which I'm going to write over here. I'm actually going to, can I move this? I'm not super good at that on this. I'm going to put that over here because I'm going to like write something in a second. So erase it, move it. Sorry, I apologize. Okay, so here, our radius, right? We get to 2. We plug it into the function because it's a radius, and then it's going to go around the x-axis. So it's going to be f of 2, which is 4. So that's our radius. And then the volume is pi r squared, so 16 pi times 2, so 32 pi. Okay, so far so good, I think. Let's think again about how we got to where we ended up. So we started at 0 and added delta x once. So I'm going to say that this 1 here is actually 0 plus 1 times delta x. To get to 2, we could say that we were at 1 and we added delta x, but we want a general process. So I'm going to instead say that this is 0 plus 2 delta x's. And if you look, that's exactly what we did. We started at 0 and we added delta x once and then added again. So that'll give us 0 plus 2 delta x's. So the next thing we're going to do is, I'm running out of colors, we're going to start at 2 and go delta x over, which takes us to 3. That's the right endpoint. So 2 was the left endpoint, 3 is the right endpoint. When we get there, we're going to go up to the function, because at 3, we plug into the function to get the radius, and we rotate here to here. So this is delta x. But instead of thinking of it as 2 plus delta x, let's think of it as 0 plus 1, 2, 3 delta x's. So it's 0 plus 3 delta x's. And then that just took us to 3 because delta x is 1. So f of 3 is going to be 9, right? Because it's always x squared in this case, because the function is x squared. Doesn't need to be x squared. Can't say that enough. Could be x cubed. It could be things you just don't want to do by hand, which is why it's x squared. Okay, and then the volume is going to be pi r squared, and then times h. And I'm just realizing that I got something wrong, right? Because it's pi r squared h. So this is actually just, where's my color? It's actually just 16 pi. No, time, yeah. What is happening? Pi r squared h, 16. Okay, so h is 1 for all of these because h is delta x. Let me in fact make a note of that. H equals delta x, so that I don't mess it up again. So in this case, this will be easier than I was initially thinking, because it's pi r squared times 1, because h is 1. So this will just be 81 pi. And let's do it again. So this is taking a while because we're developing an idea. First time you do something, it always takes a little bit longer. Also, I don't have like any other really great colors. So I'm gonna go with this, go over. The right endpoint is 4. So we could think of that 2 ways, as 3 plus delta x. But better, think of it as 0 plus 4 delta x's. And we're in the 4th cylinder. So x sub 4 is going to be 4. Okay, so here we go. It's going to be 0 plus 4 delta x's, which is 4. So we find the radius at x sub I, that'll be 16. And then the volume is pi r squared h, but h is 1 because h is delta x. So it's going to be 256 pi. All right, so our approximation is going to be the sum of all of these. So what is that going to be? Oh, I didn't know this was going to be on the test. So 12, 14 I get. So 4, carry a 1, that's 10, that's 5. Carry, I think, a 1, so I get 354 pi. Does that seem reasonable? 256 plus like less than 100. Yeah. Okay. So my approximation, I'm going to say V is approximately 300. What did I say? 354 pi. Okay, that's an approximation using 4 cylinders. Look at the difference. So 354 pi using 4 and 544 pi using 2. We got, this thing is just bouncing. We got way closer. Well, way more accurate. And it got smaller, and it makes sense that it gets smaller because if you look, we're always over counting. So like every time we do this for this particular function, we're going to get a smaller number. Every time we increase the number of cylinders, we'll get a smaller function, a smaller number. All right, so what is this? This is a really big deal. And you can actually see if you look and cheat a little bit in the box below, it's there. So this is going to do the whole thing in one shot on the calculator. How is it doing that? Well, let's see. Delta x, in this case, was where we end, which is 4, minus where we start, which is 0, divided by 4. So that'll just be 1. X sub I, we said was 0 plus I times delta x, right? So when we were in the first rectangle, we did 0 plus 1 times delta x. When we were in the second, we did 0 plus 2 times delta x. For the next one, we did 0 plus 3 times delta x. So in general, we're just doing 0 plus I times delta x, which in this particular case is actually just 0 plus I, so just I. Not the imaginary I. Don't use the imaginary I. And then what else is happening here? So f of x sub I is the radius of our cylinder. And then the volume of anything. So I'm going to say the volume sub I. The volume of the ith cylinder is going to be pi, the radius, which is f of x sub I, squared, delta x. And then if I want to add them all up from I equals 1 to I equals 4, I'm going to use a summation. Summations are the scary. Oh my word. That went poorly. Let's see here. There we go. I think that's better. I equals 1 to 4 of v sub I. Okay, so kind of summarized below, but it's good to like talk it through. What I'm going to do is I'm going to use the calculator to just generate this so that you can see that it works. And then I'm going to cut this and come back in another video to do something else. So I'm going to share the calculator. New thing, f of x is x squared, because that's what we're still working with. And what I want to do is summation. So in the templates, you'll find the summation. I want to go from I equals 1 to I equals 4, so 1 to 4, of, I want to do pi. I would say that's by far the most forgotten thing. Everyone always forgets it. The radius is f of x sub I. X sub I is 0 plus I. Square the radius, multiply by delta x, which is 1. So I'm going to press enter, and I get that. Can I modify this a little bit? So let's try to do the one that only had 2 cylinders. So I would go from I equals 1 to 2, right? You always start in the first cylinder and you end in the last cylinder, which if you're doing 2 would just be 2. So from 1 to 2. My delta x changes though, right? So it's going to be I times delta x was 4 minus 0. So it's where you end minus where you start, where you end minus where you start, depending on how this video is flipped, divided by 2. So the radius is f of 0 plus I delta x. F of 0 plus I delta x is that. Square the radius, but then this is delta x, which is 4 minus 0 divided by 2. You get 544 pi. That's the answer that we had gotten before. Can we make this more general? That's like the question that we want to answer. The answer is definitely yes, but I'm going to stop this here and come back and probably do that in the next thing. So hope you're finding these helpful.